at the back of chapter 20, there's a question called Scientific Inquiry, Draw It, and it has this data matrix, and it tells you to draw a tree depicting these relationships in two ways to see which one is the most parsimonious. One way will be the way you think is best. The other way will be to force tuna and dolphins to be sister groups. So that way, you know, you could say dorsal fins are homologous rather than analogous, and to see which tree is most parsimonious. And we're going to use these numbers here, so keep track of these numbers as we draw the tree. All right, so, oh, sorry, I'm going the wrong way. There we go. So let me go ahead and try this. We're going to, let's pick yellow because it stands out pretty well. So here's our tree, and looking at this data matrix, if we add up the lancelets, it adds up to 0. So, you know, backbone 0, hinge jaw 0, forelimbs 0, so on and so forth. That is likely that all adds up to 0, which means it's probably our outgroup. That's one way to determine the best outgroup there. So that's the lancelet. Lancelet. Okay, the next group then we're going to put as the lamprey. They're kind of in the order which they probably fall, at least for the most part so far on here. Lamprey. Lamprey. Then tuna. Then salamander. Right. Turtle. I'm going to put turtle. I'm going to draw this a little bit bigger here. Leopard. And lastly, dolphin. Remember, these nodes can rotate, so it doesn't matter which one's on the end, leopard or dolphin. Okay, backbone. That's number 1, so that would go here. That's trait number 1. Actually, no, I messed that up. Don't put that there. That would evolve here. Trait number 1. Everyone after the lancelet. Tuna have a backbone, okay, and they also have a dorsal fin. So that's number 6. Salamanders have a backbone. Yep. They have a hinged jaw. Oh, and so do tuna. Tuna have a hinged jaw too, don't they? Yeah. So that hinged jaw, which is trait number 2, should go down here. So hinged jaw is shared by tuna, salamander, turtle, leopard, and dolphin. Salamander also have 4 limbs, which is trait number 3, and tuna do not, so we'll put that trait there. The next group that branches off is the turtle, and it has all those same traits, but it also has an amnion, which is trait number 4, which evolves there, and that's also found in leopards and dolphins. Milk only shows up here, which is trait 5 in leopards and dolphins. And then, of course, dolphins also have a dorsal fin. So let's look at how many steps have evolved here. We have 1, 2, 3, 4, 5, 6, 7 different numbers here. 7 numbers, according to my tree. Now let's draw it again. I'm not going to draw this one in as much detail. I'm going to put, you know, lancelet is here. Lamprey is here. Tuna is here, but we're going to make dolphins. Here's tuna and dolphins, sister groups. Salamander is here, turtle is here, leopard is here, and dolphin is here. Okay, or I mean not dolphin, sorry. It's going to end with leopard because we made dolphin down there. Okay. What if that were the case? Well, we could still put vertebrae here, 1. We could still do hinged jaw here, 2. We could, we would have to put, let's see here, Dorsal fin could go here, so it only evolves one time now because it's a shared trait between these two groups instead of an analogous trait like it is here at the first tree. So tree number 1, dorsal fins are analogous traits, and in tree number 2, dorsal fins are homologous traits. But we have to put 4 limbs for the dolphin here, so that's trait number 3. And we have to put milk on here as well, trait number 5. Okay? All right, so then moving on up this way. Oh, and we have to put amnion on here as well, which is 4, leading to dolphin. And then amnion evolves again here, and then amnion, so after amnion, then we have trait 5 here. So, I guess trait 5 would be up here, sorry. To the leopard. Okay, so now let's look. I think I have one extra line drawn here, but that's okay. So let's look at how many traits we have. 1, 2, 3, 4, 5, 6, 7, 8, maybe 9 if I drew this right. Anyway, we can definitely see that the tree above is the most parsimonious tree. It has the fewest changes required. So that's what we mean by parsimonious trees. So you can draw it out and see. I did this, you know, I've never actually done this exercise, so I tried to do it live for you. I may have an error here or there, but you can redo it on paper, and you'll have the luxury of not being recorded while you do it, so you can check how many changes you come up with if you try to make tuna and dolphins be sister groups when perhaps they're really not. Another question from your book asks you to look at this, has a series of multiple choice questions, and I've actually used a question just like this on a test before. It says, which question is not correct? This is number 5 on page 419 of the current edition of the book. That's the 3rd edition anyway. It says, which of these are incorrect? And it has a list of questions. The one that is actually incorrect, so let me just read them to you. A, goats and humans form a sister group. That one is, so it says what is not correct, remember. So first question, goats and humans form a sister group. That's true. They share a common ancestor according to that tree. So that one's not the right answer. We're looking for an incorrect answer. Letter B, salamanders are a sister group to the group containing lizards, goats, and humans. That's true, because here's salamanders here. It's sister to all the rest of these groups, so that one's true, so we can't select that one because we're looking for a false claim. C, salamanders are as closely related to goats as to humans. And D, lizards are more closely related to salamanders than to humans. So C, salamanders are as closely related to goats as humans. Salamanders share a common ancestor here with goats and humans. They all share the same ancestor. So salamanders are equally related to goats, humans, and everybody else on here. And lizards. Lizards are more closely related to salamanders than to humans. That's false. That's the false one. D. Lizards are actually more closely related to humans than they are to salamanders. Why? Because they share a more recent common ancestor with humans right here. And that ancestor is not shared with salamanders. That's an ancestor that evolved after the split from salamanders. So lizards are more closely related to us than they are to salamanders. And so that's how you read these trees. You have to keep those ideas in mind, that those lines represent ancestors that have evolved that we may not know a lot about, but we know that they theoretically existed. Okay? And remember, these trees are hypotheses. If we find new evidence, we might have to move things around. This is science, not dogma. We have to change our ideas when we find new evidence. All right, I may have an exercise or two for you to do up on Blackboard. I don't have it created yet as of the time I made this video, but I will try to make sure you have some things to practice to work on your cladogram building skills.